Okay, in example 2 here, I also want to find the rational roots, but we'll add kind of an extra little thing here. Let's find all the rational roots of 15x to the third minus 32x squared plus 3x plus 2 equals 0. So same process as before. Let's list out our possibilities for the numerator and also our possibilities for the denominator. All right, I'm going to go back up to the top here for a second. Remember that our numerator, p, has to be a factor of a sub 0. It has to be a factor of our constant. So in this case, the numbers that multiply to 2, our options are pretty limited. We could have plus or minus 1, plus or minus 2. The denominator, up here, q is a factor of a sub n. It's a factor of our leading coefficient. We have a lot of options here, numbers that multiply to 15. We could have 1 and 15. We could have 3 and 5. And again, any combination of positives and negatives there. So when I list out my possibilities that we have to check, we have a lot. Okay, I could have 1 and 1. I could have 1 and 15. Or negative 1/15. 1 and 3. Or negative 1/3. 1/5. Or negative 1/5. Okay, we have to check all of these. But then we also have to check if the numerator is 2. So I'm going to continue that down here. More of our possibilities, we could have 2 over 1, or negative, 2 over 15, or negative 2/15, 2/3, or negative 2/3, 2/5, or negative 2/5. A lot of possibilities that we have to check here. Now, if you don't necessarily want to check all of these, keep plugging them in your calculator. I'll show you guys a shortcut. All right, again, to do this, the way I usually like to do this, instead of having to actually plug in each of these numbers to my equation, is to go into y equals and type in your function, 15x cubed minus 32x squared plus 3x plus 2. And then let's go to our table. My calculator is already set, so it's on ask. If you want to clear it out again, you could go back to table set, auto, and then back to your table set and ask. You don't necessarily have to do this, but it'll make it so your table's blank again if you like that. It doesn't really matter. Okay, let's start checking. If x is 1, y is negative 12. If x is negative 1, y is negative 48. If x is 1/15, we get 2 point something. I'm going to say 2.06. If it's negative 1/15, we get 1.66. One-third, we get 0. Oh, that's awesome. That's one of our roots. Okay, now I'm going to pause for a second. This strategy is actually going to be really good too in case not all of our roots are rational. We don't necessarily know. We might finish filling in this table and find out that this is our only rational root, like we saw up here. Once I find my rational root, I'm going to do synthetic division. Because I know, since this is a root, x minus 1/3 times some other stuff is going to equal my whole polynomial. This other stuff is going to have to be quadratic. So we can do division. And since I'm going to divide by something that's linear, we can use synthetic division with 1/3 in our box. And don't be scared by the fraction. We'll put our coefficients. And do our synthetic division. We bring down our first number. 15 times 1/3 is 5. Add straight down, we get negative 27. Negative 27 times 1/3 is negative 9. Add down. Negative 6 times 1/3 is negative 2. Add down, we get no remainder. Remember again too that this is our remainder. These are our ones. This is how many x's we have. Negative 27x. And we have 15x squared. Right. So let's find out when this equals 0. And you could do this a couple different ways. This one actually factors, which means we have more rational roots. But if this wasn't factorable, we could always use the quadratic formula to finish solving. And if I want to factor this by grouping, I know 15 times negative 6 is negative 90, negative 30 and positive 3 add up to negative 27. So we could factor this by grouping here. Factor out of 15x from these first two. And factor out a 3 from here. Come up to the side here. Zero product property. X minus 2 equals 0 and x is 2. And 15x plus 3 equals 0. Subtract 3 and divide by 15, which is negative 1/5. Again, we could have gotten that both of these are roots also by keeping on filling in our table here. But if you're ever asked to find all roots in general, not just all rational roots, this is the strategy that you would want to use.